Now let's do some lens problems. Remember for lenses, if it is a converging lens, the focus is positive. If it's diverging, the focus is negative. The magnification is always minus your image distance over your object distance. It's also your image height divided by your object height. Your image is real if your object distance is, if your image distance is positive. It's virtual when your image distance is negative. It's enlarged when the absolute value of the magnification is greater than 1, and it's reduced when the absolute value of the magnification is less than 1. We only really have one formula, and that's 1 over the focus is 1 over the image distance plus 1 over your object distance. Remember, your object distance is always positive. Your image distance can be positive or negative, and that, of course, determines whether you have a real or virtual image. Now, an object is placed 20 centimeters in front of a converging lens. So I know my object distance here is 20 centimeters, and the lens is converging and has a focal length of 10. That tells me the focus is positive 10 centimeters. Now, you don't have to put the positive. Find basically everything. So 1 over F is 1 over SO plus 1 over SI. Go on and put your numbers in. 1 over 10 is 1 over 20 plus 1 over SI. And when you solve this, you get 1 over 10 minus 1 over 20 is 1 over SI. Now I'm just going to get a least common denominator here, and that's 20. So let's see, I multiply this by 2 over 2. So 2 minus 1 is 1 divided by 20 is 1 over SI. So my image distance is positive 20 centimeters. So that's my image distance. The magnification is minus SI over SO. So it's minus 20 divided by 20, or negative 1. So let's see. This is a real image, and it's real because the image is positive. SI is positive. It's inverted because the magnification is negative, right there. And the magnification is 1, so it's neither reduced or enlarged. It's kind of a trick question. Now, what if I take the exact same object? All right, so SO is 20 centimeters, but this time I'm going to put it in front of a diverging lens, a focal length 10. That means the focus is negative 10 centimeters. I won't necessarily tell you it's negative. You need to know that because it's a diverging lens. Find basically everything. All right, 1 over SO plus 1 over SI is 1 over F. It's okay that I wrote it backwards. So 1 over 20 plus 1 over SI is 1 over negative 10. Now I'm going to get SI by itself. So 1 over SI is 1 over negative 10 plus 1 over 20. Now I'm going to get a common denominator of 20. Now, so that means I have to multiply this by 2 over 2. So 2 minus 1 is, or 1 minus 2. Oh, crud, I left off a negative sign. Oh my gosh. Okay, so negative 2 minus 1, so this is negative 3 over 20 is 1 over SI. So SI is negative 20/3. So it is negative 6.67 centimeters. All right, let me switch pen colors here. Magnification is minus SI divided by SO. So it's minus. SI is negative 6.67. That's a 6. Divided by 20. So the magnification is positive 0.33. So let's see. SI is negative. And that tells me we have a virtual image. What else do we know? The magnification is positive, so that tells me it's up right. And finally, I know the magnification is 0.33, which is less than 1, so it is reduced.